All right, today's lesson is the real number system. It's lesson 9-2. Don't forget to put the date in the top right-hand corner. I want to remind you guys what I expect from you. When it comes to the example, you can write down the notes, and it would be a good idea if you did, but if you don't choose to write down the notes, that's fine. But when it comes to your turn, you must write down the question, show the steps on how you found the answer, and then solve it. And then when you come in the next day into class, we're going to go over those questions and make sure you understand the lesson. So that's what I need from you as far as being students. So at this point, before I go forward with this lesson, what I want to do is actually talk to you about the real number system. And the real number system, the best way to think of it is this way. If you had a big, huge circle, okay, and within that circle, you have a little circle in the middle, and we call it N for natural numbers. Okay? Now, natural numbers are numbers like the number 2, the number 6, the number 7, 8, 5, 100, 1,000, whatever. That's the first type of number. The second type of number that is also within this whole big circle, which encompasses the natural numbers, would be called the whole numbers. And the only difference about whole numbers is they have the number 0, okay? But they also have the number 2 and the number 6 in there as well. So you have natural numbers and you have whole numbers. Natural numbers are within the circle of whole numbers. The next type of numbers you have are called integers. And integers, the only difference with integers is they could be positive 2, they could be positive 6, but then they could also be negative 2, negative 6, negative 4, 3, a lot of different numbers, okay? So integers include whole numbers and they include natural numbers. Now, the next type of numbers we have are called rational numbers. And rational numbers, and we'll put rational so you understand this word, rational numbers are numbers that can be a fraction like 3/10. It can be a decimal like decimal 2, because a decimal 2 is really 2/10 or 1/5. So 0.2 is a decimal. It could also be a number like 0.8 repeating, because 0.8 repeating is really also a fraction 8/9. So basically we have all these rational numbers, okay? They could also be negative fractions as well, like negative 2/3. That's a rational number. You could even have the square root of 25 as a rational number. Why? Because 25 equals 5. So any number that could be written as a fraction, because I could take this number 2 and put it over 1. It's a fraction, right? It is still an integer, but it's a fraction if you want to write it that way. We don't have to, but you can. All right? So these are types of rational numbers. Now, there's also something called irrational numbers. And irrational numbers, the thing you have to understand about irrational numbers that are not included in all of this is that irrational numbers, the rule is they never terminate, and they never repeat. So if I wrote down a number like 0.010010001 and put ... that would show that that number never repeats, because it's 01, then it's 001, then it's 0. There's a pattern there, but it never repeats. And it never terminates. That's what those 3 dots mean after it. The number pi is actually an irrational number. It's 3.14, and the numbers come after it are like 4159, 159, and then ... The number pi is an irrational number. It never terminates, and it never repeats. So these are important numbers to remember. Also, if I took the square root of 2 and punched that in, you would get a decimal answer that would go on and on forever, and it would never repeat and never terminate. So those are called irrational numbers. So that's the beginning of this lesson. You need to understand what natural numbers are, okay? Whole numbers, just adding the 0, and integers. and they are positive or negative numbers. And then we get into the rational. So all these numbers in this big huge circle are considered rational numbers. Okay? In fact, we could even put a big huge circle around that. Everything in here is a rational number. Okay? A natural number is a rational number. A whole number is a rational number. A natural number is also an integer, it's also a whole number. So if you get the idea that it's a whole circular thing. The numbers that don't fit into that big huge circle will be called irrational numbers, and they're the ones that never terminate and never repeat. The one last little tidbit about rational numbers, it cannot be over the number 0. A number over the number 0, like 4 divided by 0, does not work. It's impossible to get an answer. So anything that is a fraction over the number 0 is not considered rational. Okay, so what we're going to do is we're going to start with the real number system, and there are 3 examples here. Alright, so example number 1, as you can see, this number is a natural number, a whole number, an integer, and a rational number. So, pretty simple using those notes that we've been given earlier. Here we have a negative 72 over 6, but this is a fraction. So the question is, negative 72 over 6 equals negative 12. And since it equals negative 12, this would be an integer. It's not a whole number or a natural number because it's not positive. So it's a negative number, therefore it happens to be an integer and it happens to be a rational number. Okay? Here's the next example, square root of 225. Well, what we have to do is we have to find out what the square root of 225 is. It happens to be 15. 15 is a natural number, it's a whole number, it's an integer, and therefore it's a rational number, so it encompasses all 4. Okay, what about this one? Negative 2 and 46 repeating. What do we do with this one? So it's a repeating decimal, and if it's a repeating decimal, then we know that it at least is a rational number. Because really, 246, or 2.246 repeating, with the 46 repeating, is really 244 over 900. So, rational number, but not a whole number, not an integer, and not a natural number. And it's not an irrational number because remember, irrational numbers never terminate and never repeat. This one repeats, therefore, rational number. Okay. How about the square root of 52? Well, when you punch that into your calculator, you see that it's 7.2110255 ... This one is never repeating, this one is never terminating, and so this number is irrational. Okay, so now it's your turn. Name all the sets of the numbers to which each real number belongs. Now you should be writing these questions down and answering them, and then you're going to want to pause, find the answers, and then move on. Moment to write that down, and we will move on. So, example 2a. Now we have to decide, the little blue dot, is it greater than, square root of 125, is it greater than, less than, or equal to 11 and 7/8? Well, what we have to do is, we have to change these numbers as decimals, express them as decimals. And then you could graph the numbers if you wanted to, but I think by just looking at them we can figure out what the answer is. So, square root of 125 is 11.18033,989, and 11 and 7/8 is 11.875. Why I said you could just look at these is the 11s are the exact same, but after the decimal, you'll notice that the 8 is larger than the 1. So 11 and 7/8 would be greater than, and you can see it here, than 11.18033,989. Therefore, we know that since square root of 125 is to the left of it, it's going to be less than. Now, the next thing they want you to do is order these from least to greatest. This is important, you guys make sure that you know if it says least to greatest or if it says greatest to least. This one says least to greatest, so we're going to do the smallest one to the biggest one. So first of all, we have to put them all, represent them all as decimals. So 6 1/4 is 6.25. Square root of 38 is 6.16, yada yada yada. 6.5 repeating would be 6.5555 and going on and on forever. And the square root of 36 is 6. So now we're going to order them from least to greatest. And when we do that, we'll see that the square root of 38 would be the smallest. Then the next one would be 6 1/4. And then it would be 6.5 repeating. Ah, Mr. Visser, you made a mistake. Okay, so now we have to express each number as a decimal and compare the decimals. You'll see that the square root of 36 is the smallest, then it goes to the square root of 38, and after that it would be 6 1/4, finally followed by 6.5 repeating. And you can see that on the number line that that's the case, and so putting them in order from least to greatest is, as I said, square root of 36, square root of 38, 6 1/4, and 6.5 repeating. Now it's your turn. Go ahead and write these two questions down, and once you have them written down, solve them, and we'll look at the answers tomorrow, first thing when we get to class. All right? So now would be a good time to pause, write down the questions, and then go from there. Okay, example 3a. Now, we have to solve w squared equals 165. We want to find out what w is. Okay? So now we're going to be able to use our calculators. And so the way we do this is we write the equation down first. So step 1 is write the equation down. Step 2 is put a square root sign over the w squared and over 169. Now, when you do a square root of a variable squared, the answer is always the variable w. And then find the square root of 169, we punch that into our calculator. Now remember, it could be a positive or it could be a negative. We don't know, so we have to find both of those answers. So I'm going to square 169, and I know that it's 13. So w could be 13 or negative 13. Why? Because 13 times 13 is 169, but a negative 13 times a negative 13 is also 169, because we know from our integer rules that a negative times a negative is a positive. So the solutions for this question would be 13 and negative 13. The next question, we have r squared equals 50. We're going to set up the equation again. R squared equals 50. We're going to square root both of those, and we are going to get r equals 7.1 approximately, because when you punch it into the calculator, it's not exactly 7.1, so that's why we have the little approximately sign. Okay, or it could be negative 7.1. You do it to the nearest tenth because that's what the question asked you. So those would be the solutions, 7.1 and negative 7.1. All right, here's your turn. Go ahead and write them down. Press pause, find the answers, and we'll look at them tomorrow. And that's the end of lesson 9-2. Don't forget, show your work, show your steps, and we'll be looking at this tomorrow.